All right, so let's take a look at this lesson today. So we're looking at, it's called linear combination property. What the purpose of this is to take like a sine plus a cosine. So let's just talk about the purpose. Why do we need this property? If we have like a sine plus a cosine, we can use this property to turn it into just one cosine expression, which is kind of powerful if we need to graph it or solve it or do stuff with it. So it's quite helpful to be able to turn two things into one, and that's what this property does. Now, you will not have to memorize these formulas. They will be given to you. This isn't a formula that's needed to be added to your memorization list. Of course, you know unit circle is. That's like non-negotiable. You have to know the unit circle. But this you don't, and I'll put a note here. No need to memorize formulas. They will be given. Now, I'm not going to tell you what they are used for, but I would just write them up there. They would be given. Okay? So let's kind of pick apart what we're doing here. So we're going to turn, a number cosine x plus a number sine x into a cosine x minus d. So the things that we want to find are a. We want to find a. This is the formula to find a. In order to find a, you're going to do the square root of this number, b and c. That's what you're going to do. So the square root of b squared plus c squared, that's going to give you a. That's the most straightforward part of this formula. That's not too bad. We should be able to do that. We just pick out the number in front of the cosine, pick out the number in front of the sine, square them, square root them. We're good to go. D is a little bit more difficult to find because because of the circumstances. So let's look at what D is. So D, this part right here, we're going to use this formula, D, and we're going to do arctangent of C over B. Now let's think about what that means. So C is the number in front of sine. What in the unit circle, which variable is sine matched to, X or Y? Y. It's matched to Y, isn't it? And so it kind of makes sense that C, the number with sine, is in the numerator. Again, you don't have to memorize this. We will give it to you, but I want you to understand that makes sense because tangent is sine over cosine. So that makes sense that the C would go in the numerator. And then in the unit circle, what variable is cosine matched with? X. It's matched with X. And so that makes sense that that number B would be in the denominator. It's like it's y over x. Okay, so that kind of makes sense. And this we may need a calculator for to do the arctangent. If it's not a unit circle value, we're going to need a calculator. Now here is the note that is really critical. And I wrote a whole note out about it because when people make mistakes, when students make mistakes, it's typically because of the angle. It's typically. The quadrant for angle D depends on the sines of C and B. Okay, that is critical. It depends on the sines of C and B. And we're going to look at that in specifics. Okay, so that is a big asterisk right here, right here. That is the place when students make mistakes, it's typically right there that they make a mistake, is placing the angle measure in the proper quadrant. And I have a couple of examples where we'll dig into that. Before we get to the examples, I just want to do some vocabulary with you. So on this left graph, if you add like 3 sine plus 4 sine, you're going to get, 7 sine, right? Those sinusoids. So a sinusoid, another vocabulary word, a sinusoid means cosine and sine. Those are sinusoids. Okay, so that's what that means. So they're said to be in phase. When we add them together, they're in phase because the high and the low points happen at the same angle value. So this is just vocabulary. You don't have to memorize this. I just want you to understand if they say that the sinusoids are in phase, they're talking about that they're matching up, that like all their maximums are in the same spot. You know, all their minimums are in the same spot. What I mean is angle measure. They're in the same angle measure. Those are called in phase. So the ones we're going to be dealing with are not in phase. So here, if you look at the graph on the right, if we're going to add 3 cosine and 4 sine, those have different phases, right? And they're not in phase. So you can see that when we add those two, we get something entirely different. We get h of theta, something entirely different that doesn't have the same maxes and mins as the two individual ones. So that's just like a visual picture of what we're going to be doing. You're not going to have to graph all 3 of those functions or anything, but it's just giving you a picture, a visual picture of what it is that we're doing. Okay? So let's do a few examples. And for your homework and for these examples, you will need a calculator. If you have one with you, that would be handy. If you don't, it's okay. You can just watch as I do my calculator. So before we start, let's go ahead and write the formulas up at the top of the page, just so we have something to refer to. So we've got b cosine plus c sine equals a cosine x minus d. Okay, so let me give you some, well, let's write the little baby formula. So big A is equal to square root of b squared plus c squared, and d is equal to arctangent of c over b. Now I want you to notice the way that the functions are lined up with the cosine in front and the sine in the back. There is an example on your homework where they are flipped. You just need to rewrite it with the cosine in the front and the sine in the back. So make yourself a note. So if these are switched, rewrite them. Do not try to work it with them switched. Rewrite them. You need the cosine coming first and the sine coming second. And the way you can remember is x comes first, then y, right? When we write points, it's x and then y. So be sure cosine comes first, sine comes second. All right, just a note, because I do have one on the homework where it's reversed. So you need to rewrite it, okay? All right. So we're going to rewrite that. That's fancy words as a single cosine with a phase displacement. That's fancy words for just use the formula and write it as one cosine. That's all that means. Just use the formula and write it as one cosine. Okay, so let's do that. So let's do, the easiest one is A. Let's find A first. A is the square root of negative 8 squared plus 3 squared. Remember, if you're using your calculator, which you probably will for most of these, remember that you would need to put the negative 8 in parentheses. If you don't, the calculator is not going to understand what you want, and it's going to make it a negative number. So please be sure, if you're using this with your calculator, to put that negative 8 in parentheses. So let's see, 64 plus 9, that's what, 73. So we've got the square root of 73. That's our A value. That's usually pretty straightforward. Students typically do not have trouble finding A. We should be able to do that without a problem. Okay? Finding D is a little challenging. So let's just write the formula out. D equals arctangent of C, which is the one in front of the Y, right? 3 over negative 8. Now, before we do any work with it, what I want to do is I want to figure out which quadrant we're in. Like I said, this is the danger zone right here, the quadrants. So how do we do that? What do we do? So what we do is we're looking at these numbers in front of the sine and cosine. That's where we're focusing on the numbers. And we're going to say, so if we look at the negative 8, that means that x, we want to find the quadrant where x is negative, Why did I use x being negative? Because it's cosine, right? Because it's cosine. X is negative, and I want y to be what? Positive. I want y to be positive. So now we need to think to ourselves, or together, I guess, which quadrant would x be negative and y be positive in? Quadrant 2. So I'm going to put my triangle over here just to remind me that's where it goes. Tangent is opposite over adjacent. So this angle measure right there is D. D needs to be in the second quadrant. It must be in the second quadrant, okay? Now some of these examples, actually these two, we're going to be doing in radians, but so these two are both in radians, but on your homework, some of the examples are in radians and some are in degrees, and you need to pay attention to which is which, okay? You need to pay attention because it's going to change the numbers just drastically. So right here, we're in radians. So I'm going to go to my calculator. Okay, is everybody good so far? We know we need to do arctangent of 3 over negative 8. Okay, so I'm going to pull up my calculator. And I want to add a calculator. I want to be sure I'm in radians. Remember, right up here is where you change it from radians to degrees. And on the problems with degrees, you're going to need to pay attention and switch it back and forth, okay? Just remember, we just click up there and it'll go back and forth. So arctangent is this tangent to the negative 1. This is arctangent. It's just written, that's just the way the calculator likes to write arctangent, tan negative 1. And then I want the fraction, so I'm going to do control divide. Gives me a fraction. And it was what? It was 3 over negative 8. Okay, that's what it is. I know I'm in radians. That's great. I hit enter. Well, I'm going to hit control enter because I don't trust this calculator. Control enter, and that's my decimal. All right. So does everybody have that decimal? I'm going to go back to my screen. Are we okay? Let me go back to my OneNote document. Okay. So this equals negative 0.35877. Now we need to ask ourselves, is that angle in quadrant 2? It's a negative angle measure. It is not. So let's say we are having a little trouble figuring out where with radians. We know this is 0 radians. This is pi over 2. So I'm going to, this is pi. So we're going to do like a 3 here. I'm just rounding. And half of 3 is 1.5, right? And 3 plus 1.5 is like 4.5. So this is a round. And if we went all the way around, we get to around 6. Just around 6. This helps you decide where those angles are for radians. Okay? So if I have a negative 0.3, which quadrant do you think that's in? The 0.3 would be in the first quadrant, but it's negative. So it's in, it's in the fourth quadrant. Very good. It's in the fourth quadrant. And do I want my angle in the fourth quadrant? No, I want it in the second quadrant. Now, if you recall, tangents period is pi radians, or if you're in degrees, what is it? Right, 180 degrees if you're in degrees, right? That's the period. So if we're in the wrong quadrant, all we have to do is add or subtract pi if we're in radians, or add or subtract 180 if we're in degrees. That's all we have to do to get us in the right quadrant. Well, let's check that out. So we're going to take the negative 0.3587. I'm going to pull my calculator up. I'm going to take that number. I'm going to highlight the number and hit enter, which pulls it down. And then I'm going to add to it pi. I'm going to add pi to it and see what that gives me. It gives me 2.7828. Okay, 2.7828. So I'm going to write that on my paper. 2.7828. Isn't that weird that I call it a paper? I'm so old. So I take the negative 0.35877. I add pi to it, and I get 2.7828. Now, we need to ask ourselves, now, is that angle measure in the second quadrant? It is, right? Because isn't that number between 1.5 and 3? That's the only reason I wrote those numbers up there, is to help me, you know, because it's kind of hard. If I ask you, oh, what's pi over 2? Well, I don't know, right? It's 3.1415 divided by 2, so around 1.5. All right, so that's good. Now we're good. So let's write our final answer. So we've got y equals the square root of 73 cosine of x minus 2.7, and we're rounding to the thousandth, so I'm going to stop at a 3. Okay, how we doing? Excellent. And that's really about as hard as it gets. There are a couple of other nuances I want to talk to you about. Let's pretend, and we'll just go to this one we just did. Let's pretend that there was a 3 theta and a 3 theta here. Okay, I'm pretending. So let me write it in a different color. We're pretending. Let's pretend that there was a 3 theta and a 3 theta here. The only thing that would change is I would put a 3 right there. Nothing else would change. I would just stick a 3 in front of the x in my answer. I wouldn't change my calculations for A or D, and those two numbers have to match. I am not going to give you anything where they don't match. Okay, they will always match. And the only thing that it does is makes, you know, x not just be a single x like a 3x. That's it. That's all it does. So I'm going to pull that out. I just want to, you know, note that, so that when you see that, it doesn't freak you out. Okay? Are we all right so far? Okay, so let's do our last example. We're still in radians. I want to still look at my little formulas. So we want a single cosine. Okay, great. That just means use the formula. So A is going to be the square root of 1 squared plus -1 squared. So that's what, square root of 2. So A, pretty straightforward. Okay. D is going to be arctangent of, let's see, it's y over x, -1 over 1. Now, I want to, before I try to figure that out, I want to do my, really, you should stop yourself before you go to calculate. You should stop yourself and figure out which quadrant it's in, because this is the most dangerous part. This is where the most mistakes happen, is not paying attention to the quadrant. So what do I want? I want x is positive, and I see that y is negative. So we need to go to the quadrant where x is positive and y is negative. Which quadrant would that be? 4, quadrant 4. Very nice, ladies, quadrant 4. And so we know that, you know, tangent is opposite, so what, -1 over adjacent. Okay, so we're in quadrant 4. Now, let's think about our unit circle values. So if we were looking at the unit circle, you know, we're going all the way around the unit circle, all the numbers out here, right, like this is, what, this is 1, 0, right? So 1 and 0, those are unit circle values. What other unit circle values do we have? We've got, yep, root 3 over 2, 1/2. What else do we have? Root 2 over 2, root 2 over 2. And then just, it keeps just going, right? Just different combinations of that. So if your arctangent is of any of those numbers, you do not need a calculator. Okay, you do not need a calculator if it's any of those numbers. So, and -1 is one of those numbers, right? We could do tangent, arctangent of -1. So let's think about that. We want to be in the 4th quadrant. Tangent is sine over cosine. We want those numbers to match. Where do sine and cosine match? And the 45, 45, 90s, right? Root 2 over 2 over root 2 over 2. I want my y value to be negative and my x value to be positive. So I need to figure out what angle measure does that match. And I can do my counting thing, right? Let's count around. So what is that angle measure? It's so 1, 2, 3, 4, 5, 6, 7. That angle measure would be 7 pi over 4. Right? That's my angle measure. Is everybody okay? All right, so now let's just fill in the formula. We're done. We're basically just need to fill in the answer. So y equals the square root of 2 cosine of x minus 7 pi over 4. And that's our answer.
Wait, why is it just, oh wait, never mind.
Is that okay? Is everybody all right? Okay.